So Vs equals I naught times R1 plus R2. Yes, that is correct. So I naught equals Vs over R1 plus R2. Yes, that is correct. I found our mistake. Alpha I naught should be equal to negative V naught over R3 minus V naught over R4. We have found our mistake. So alpha I naught here should be negative V naught over alpha. We lost our minus sign somewhere. So when I did my substitution, I should have Vs over R1 plus R2 equals negative V naught over alpha times 1 over R3 plus R4. So V naught equals negative alpha Vs over R1 plus R2 times 1 over R3 plus 1 over R4. The good news is nothing changes except for V naught should have a negative sign. So V naught should have a negative sign, okay? I am going to put this in my calculator this time because I don't want to make a mistake again. And we're going to make sure that that number is indeed correct. Thank you for the 22 people hanging out in here with me. Thank you for the 2,000 hanging outside. Negative 0.5 times 1 over 4 plus 1 over 5. Okay. That is negative 0.225 volts, okay? So V naught is negative. So we were right. Everything's correct, except this should have been a minus sign, negative 0.225 volts. Okay, the good news is that is going to now change this to be delivering. So that means that now my dependent source is also delivering power because that flips the voltage. So the current is still 0.225 and the current is still 0.5 and the voltage being delivered is still 0.225. So I need to now flip that number. If you have questions, yes, we're doing Ohm's law and we're also doing P equals V times I. If you have questions, please put them in the chat and somebody who's been hanging with me for a minute will answer them for you. So now the dependent source is, because that sign flipped, it is now also delivering power, and the power that it is delivering is 0.5 times 0.225, 0.5 times 0.225, which is negative 0.1125. This is the benefit of making this table, is that I can quickly tell when there's a mistake. So right now, this is actually DC circuits. It's an engineering course, but this is algebra we're doing inside of an engineering course. So what I now have is 5.1125 watts delivered. 5.1125 watts delivered. And I need to show that I have 5.1125 watts absorbed. So I am going to take 0.225 times 0.05625, 0.225 times 0.05625, and that is 0.00127 watts, 0.00127 watts absorbed. Then I'm going to take 0.225 times 0.045, and that's 0.01 watts absorbed, okay? Hopefully, although I have a little bit of rounding error here, you guys can see that this does indeed sum to 0. 5.11 watts delivered equals 5.11 watts absorbed.